With that basics of serial communication, we will try to know much more about the serial communication basics. Basically, there are three methods of transmission in the serial communication. One is simplex, another one is half duplex, another one is full duplex. In simplex transmission, the data will be transmitted from the transmitter to the receiver. Whereas in the half duplex, the data will be transmitted from the transmitter to receiver, and from the receiving point to transmitter also it can be sent. But cannot be done both at a time. The data can either from one point to another point, or the data can come from another point to the initial point, but not both at a time. Whereas in the full duplex, the data can be transmitted from the point A to B and B to A simultaneously. I'll repeat. If I consider one as a sending point A and a receiving point B, in the simplex, the data can be transmitted from A to B. That's it. B to A is not possible. So what is an example for this? We can consider a good example is printer, computer printer. That is, the data can be sent from a computer to printer. From printer to computer, it is not possible. Such method or transmission is called as simplex transmission. Half duplex is the data can be sent from A to B and also from B to A, but not both simultaneously. A good example for this is walkie-talkie, wherein which the data can be sent from both the sides to both the sides, but not simultaneously. Whereas in a full duplex, the data can be sent from A to B, B to A is also possible. Simultaneously is also possible. A good example is telephonic conversation. So these are the three methods of transmission which is basically used in serial communication. There is another classification in a serial communication, that is, serial communication can be asynchronous or it can be synchronous. So in the synchronous serial communication, a block of data will be sent at a time. Whereas in the asynchronous communication, single byte will be transmitted at a time. In synchronous communication, the events are referenced to the clock. Whereas in the asynchronous, as the name itself indicates, there is no clock. The bytes will be separatedly sent, but it will be associated with start and stop bits. An example for synchronous is SPI and I2C bus, whereas for an asynchronous, a good example is UART. That is Universal Asynchronous Receiver Transmitter. To support the serial communication, special interfaces are built in the 8051 microcontroller, and the special interface is called UART chips. As I named earlier, it is nothing but Universal Asynchronous Receiver Transmitter. And in few microcontrollers, we do have also USART, that is Universal Synchronous Asynchronous Receiver Transmitter. And our 8051 microcontroller has built-in UART, which will be supporting for serial communication, which is acting as a sender and a receiver too, that is receiver and a transmitter too. So whenever the data has to be sent in a serial communication, the data has to be framed first. That is how exactly the data will be packed. That is called as framing. So let's see what exactly it is. So the data always will be in the form of zeros and ones. To have a sense of synchronization between the transmitter and the receiver, to make that the data is a sense of data, both the transmitter and the receiver has to agree on a set of rules to know which is exactly the required data which has been sent and to know which is exactly the required data which has been received. So in order to achieve this, the transmitter and receiver has to agree on a set of rules, and that set of rules is called as a protocol. So what is exactly the protocol? Which gives a set of rules which makes us, the transmitter and the receiver, to understand what is exactly the data has to be transmitted or the data which has been received. So this protocol indicates or gives an information about how the data is packed, how many times, how many bits constitute a character, when the data begins and when the data ends. These set of rules will be given by a protocol. If the data, suppose a 8-bit of data will be framed with a start bit, stop bit and all. This indicates the data framing.